This is R.D. Sharma Solution, Class 12, Chapter 8. Solution of simultaneous linear equations. Exercise is 8.1. Solve the following system of equations by matrix method. Now, the linear equations or system of equations can be solved by various methods. One of them is matrix method, and these equations that you see here is an equation of a line. For example, y equals mx plus c, or ax plus by plus c equals 0. These are the lines. So when we have this y equals mx plus c or ax plus by plus c equals 0, then when we have x, y, z also, then we are talking about plane. So in order to solve this equation, we are essentially solving the intersection of these two lines. So how do we use the matrix for that? The way is, this matrix has to be formed. How to form this matrix using these system of equations? So step by step we will know how to solve this question. So first is how to write this equation first. The equation form is 5x plus 7i y equals negative 2. I am taking 2 on the right hand side. So constant has to be taken on the right hand side. Similarly, 4x plus 6y will be equal to negative 3. Right? So now there's the coefficient of x and y. We will form a matrix. So the coefficient of x is 5 and 4. The coefficient of y is 7 and 6. This is the matrix. We call it as A. You can call it any letter. And what is x and y? This is x and this is y. This is we call as an x matrix, x. And this is equal to, on the right hand side, what is there? Negative 2 and negative 3. Okay. So this is Ax equals B. This is our matrix. Ax equals B. Now in order to find out x, what do you get? We will multiply both sides by A inverse. So A inverse is I. On the right hand side it will be A inverse B. So x will be equal to A inverse B. This is the whole, you can say the summary of solution. So there are various things you need to know. You need to know how to find out the A inverse. You need to know how to find out the matrix multiplication, the transpose, the cofactor. All these are the basics you need to know before even going to solve the system of equation by matrix methods. So we'll multiply this, we'll equate this, and we'll try to find out the solution. Okay, this A, because we need A inverse, so adjoint will be what? This is 2 by 2 matrix, so it's quite easy. 5 and 6 we are exchanging, so this will be 6, this will be 5. And 4 and 7 will change the sign. And this is your adjoint. This is for just 2 by 2. Now, after finding the adjoint, we have to divide it by the determinant, because A inverse is nothing but adjoint of A divided by the determinant of A. So the determinant will be 5 into 6, that is 30, minus 7 for the 28, so it will be 2. Now before that, let me tell you one more thing. How do you know that the line are going to intersect? How do you know the lines are not parallel, or though both lines are same? So they are parallel, they are same. If they are same, they are parallel, you are not going to get any solution. You will get to a solution only when the intersection point is there. So the determinant should not be equal to 0, it has to be a non-zero value. Since we have 2, so we can go ahead. So what will be A inverse? It will be adjoint of A divided by the determinant of A. So this will be, determinant is 2, so I am dividing it, and the adjoint I am writing. So this whole is your A inverse. The next one is to multiply by B. What is B? On the right hand side, you see this is negative 2 and negative 3. So first is 2 by 2 matrix, second is 2 row 1 column. So you will only get a matrix with only 2 rows. So 6 into minus 2 plus minus 3 into minus 7. This will be first value. First row with first column and second row with the first column. Now minus 4 into minus 2 plus 5 into minus 3. So 1 by 2 will apply later. So 6 to the 12 minus 12, and this is going to be plus 7 3 is 21. This is minus 4 to the 8, then minus 5 to the 15. Now 21 minus 12 is 9. So you can write 9 here. 8 minus 15 is minus 7. So 9 and minus 7, that is what you get. But you have a half also. So divided 9 by 2 and minus 7 by 2. So this is your x and y. So x is 9 by 2, y is negative 7 by 2. So this is how you are going to solve linear equations or system of equations by matrix method, 2 by 2. Okay. Now in this particular question there are various parts, and since the parts are almost similar, so I'll just skip all these, but I'm going to show you the answer so that when you are doing, you can just go back, see how we actually solved it, and then you can go ahead with the solution by yourself. So the cofactor needs to be found out. We'll see it in a 3 by 3 kind of solution, because finding out the adjoint of 2 by 2 matrix is quite simple. But you can also use the method of finding the cofactor and then changing the transpose. Here also the same thing. 5 you have to take on the right hand side, 3 you have to take on the right hand side, and then ax equals b. A is the coefficient of x and y, b, x is x and y, b is the constant which you have taken on the right hand side. I hope you'll be able to do all these because they are almost similar which we discussed, and you can have a reference here. So this solution is only for your reference. I would encourage you to first solve by yourself, then only see the solution. So this is also one of the way. Solve the following system of equations by matrix methods. Now you have x, y and z. So system of equation, this is an equation of a plane. Y equals mx plus c is the equation of a line, but x, y and z when we have, so just assume that there are two planes and they are intersecting somewhere, and that intersection needs to be found out. That will be certain x, y, z value, right? So in order to do this, we need a matrix method. So 2 by 2, 3 by 3, all these matrices will be solved by the similar method. On the left hand side you have x, y, z, so you will take the coefficient of x, y, z. But remember that the planes may be parallel, the planes may never intersect. So always see first of all that the determinant of this particular solution is giving you a proper value or not. It has to be non-zero. So the coefficient of x, y, z will be called as a, x, y, z will be called as x, and 3, 10, 1 will be b. And how do we write this? X will be equal to a inverse b. So we have to find out the a inverse. What is a? A is all these x, y, z, the coefficient. So a is 1, 2, 3. Y is 1, 3 and minus 1, and z is negative 1, 1 and negative 7. So in order to find out the determinant, let us see the determinant. 1, you'll get 3, 1, minus 1, minus 7. I hope you have a fair idea about finding out the determinant. 2, 3, 1, minus 7 for 1 and then negative 1, and then we have this 2, 3, 3 minus 1. So this is going to be minus 21 plus 1, it is going to be negative 20. The negative 20 into 1 is negative 20. So write negative 20 here. So this is minus 14 and minus 3, it is minus 17, minus 7 into 1. So plus 17 it will be. 2 into minus 1 is minus 2, and then 3 is a 9, minus 9. This is going to be minus 11. Minus 1 into minus 11 is plus 11. So 11 plus 70 is 28. 28 minus 20 is 8. So you have a very legal value valid value of the determinant of A so that we can proceed for solving the system of equations by matrix method. So first thing first is find out the determinant and see whether we can go ahead or not. Otherwise you have to say that the solution doesn't exist. Right. Now coming to A inverse. A inverse is adjoint of A divided by the determinant of A. What is determinant of A? We just found it, 8. Let us see the adjoint of A. Adjoint of A, you have to find out the cofactor of each and every value. Then the cofactor matrix will be formed and then we'll take the transpose. So I'll show you a few values of cofactor. Let us say we are finding out the cofactor of the first row. So this is C11, this is C12, this is C13, this is C21, C22 and C23. This is C31, C32, C33. Right? Now, C11, C12, C1. Let us see how this works. You already know how to find the cofactor. So it will be minus 1 raised to the power I plus j. I is the row and column. So I1 plus 1. Here also minus 1 to the power 1 plus 2. Then we have minus 1 to the power 1 plus 3. This will be done for all the values, right? I'm just showing you 3 of them. So minus 1 to the power even will always be 1. Minus 1 to the power odd will always be negative 1. So this will be, see, C11 is what we have already found this value just now. C11, this row and this column you have to leave. You have to get 3, 1, negative 1, negative 7. Similarly, C12, you'll get 2, 3, 1, minus 7, which we already did while we were finding out the determinant. So 2, 3, 1, minus 7. Then C13, first row, third column you have to leave and others you have to write all the other values. So you'll get 2, 3, 3, minus 1. And since we have already found out the value, I'll quickly write the values here. This is minus 20 we got. Here also we got minus 17 if you remember. Because you're not going to put the sign because sign is going to change just now. Some of this value will have a different sign. So I'll just write negative 17 here. Here also I'm going to write. It will be minus 2, minus 9, so negative 11. But since C11, C13 will be of positive side, the C12 will be negative sign. So it will be plus 17. I hope you'll be able to do all the cofactors. Right? Now let me write the cofactor matrix here. After we find out the cofactor matrix, we will have to take the transpose of this matrix. So I am writing all the values, minus 20, 17 and in minus 11 I told you. Other values I hope you'll be able to find out. So these are all the values. So you just have to see that these C11, C12, C13 will be replaced by the values we have found out. Other values you'll do it like that only. So let us take the transpose. So row column changing, minus 20, 17, minus 11. Here we get 8, negative 4 and 4. This is 8 minus 4, 4. So let me just write that. There is a slight change here. 4 minus 3, 1. So just read minus 3 as 4. Now you have to divide it by the determinant, that is 8. So this is the determinant divided by 8. Now A inverse into B. So you have to take multiplication of this particular value which we got with 3, 10, 1. So let us multiply this 3, 10, 1. So 1 by 8. I'll show you one of the value. Minus 28, 4 and 17, negative 4, negative 3, minus 11. And then we have, as I said, it is 4. Just read it as 4. It is not negative 3. 3, 10, 1. So multiplication, matrix multiplication is up to you. I hope you'll be able to do it. So like first value I'll tell you, minus 20 into 3 plus 8 into 10 plus 4 into 1. So x, y, z will be, so whatever value will come, let me tell you the value will come as 2488. Once you compute it, so you have to divide it by 8 also because there is already an 8 outside. So 4 divided by 8 is 3, then 8 divided by 8 is 1, 8 divided by 8 is 1. So x becomes 3, y becomes 1 and z becomes 1. Okay. So this is for 3 by 3 matrix, system of equations by matrix method. This is how you have to solve. Now this questions which are coming are almost similar to what we have done. These are the steps you have to follow, and cofactor, finding out the inverse, adjoint, transpose, all these you need to know before even attempting this kind of questions. So I'm just showing you the answer because I hope that you'll first solve. If you are stuck, then you can come and see the solution. Solve the following system of equations by matrix method. Now this can be changed to the question we have already done. So I'll just show you how it is done. Wherever you have this 1 by x, just assume it to be any letter like A. So whenever the answer will come, just take the reciprocal. That is, once you have assumed 1 by x as A, so whatever is the answer A, you can make it as 1 by x, or x will be 1 by A. 1 by y is B, 1 by z is C. You can take any letter of your choice, doesn't matter, right? Okay, so what will be the equation here? 2a minus 3b plus 3c equals 10. Second equation will be a plus b plus c equals 10. Third one will be 3a minus b plus 2c equals 30. Now this equation is quite known to you now. So you can just use 3 equation and then you can solve it. A, x, b, all you know how to do this. Okay. So a into x is b. So x will be a inverse b. X will be a, b, c. The only thing is x will be a, b, c. And a inverse I hope you'll be able to find out. So let me write the matrix for which you have to find the inverse. So this is the coefficient of A, 2, 1, 3. Coefficient of B, negative 3, 1, negative 1. Coefficient of C, 3, 1, 2. So this one is A, and this matrix A inverse need to be found out. And of course the B is 10, 10, 30. So A inverse I hope you'll be able to do. You can use the cofactor way, and then you can just take the transpose and divide it by the determinant. So whenever the answer will come, just take the reciprocal and that will be your answer. For example, the answer which came here, the reciprocal has to be taken. So this kind of questions are plenty of these. I will encourage you to do all of it, and if you have any problem, then only you can just refer to these answers which I have provided. Okay, so wherever you don't have any variable, you can put a 0. For example, this 0x, so you can put a 0 here. Same thing here, same way you have to follow. So you know, most or more question you do, you will be more proficient. Now here you don't have y, so it will be 0y. The first one you don't have z, so you can write 0z. When the matrix will be formed, it will be like this. Here also you have to make a into x and ax, b, all these, and then wherever you don't have the variable, you just put a 0. This also you'll be able to do, I hope. So these are the same question. They are just the sub part of that questions. You don't have y here. Okay. This also we have seen just now. 1 by x, assume it to be any letter. A, B, C you can take 1 by x as A, 1 by y as B, and 1 by z as C. So this 2a plus 3b plus 10c, 4a plus 6b plus 5c, 6a plus 9b minus 20c. This will be your 3 equations, and then you can form the matrix and then compute the final values by reciprocating it. Same thing here. Now show that the following system of linear equations is consistent and also find their solutions. So before we go ahead with this question, let me give you the actual theory behind it. For example, these are just lines. 6x plus 4y equals 2. You can equate it with y equals mx plus c. You can also equate it with ax plus by equals plus c equals 0, or ax plus by equals negative c. So there can be two lines which are same. If I multiply this 2x plus 3y equals 4 with 2, what do you get? 4x plus 6y equals 8. But the line has not changed. So when you have two lines and they are same line, they will be on one another. So you will get infinitely many solutions because every point can be counted. It is just one line because they both are of same line. So you have infinitely many solutions because these two lines which are single line are intersecting always. Since it is consistent because it is intersecting also, two lines same intersecting. There can be a possibility when two lines are parallel, they are never going to intersect. Parallel lines won't intersect. Then we have the third case, which is the actual solution, you can say, when you have intersecting lines. So you have to show here that first of all it is consistent, and then also to find its solution. So first thing is find out the determinant. The determinant of basically A, you have to take the determinant, coefficient of x and coefficient of y like that. So A matrix, this will be coefficient of x. So let me write the 6 and 9, and then coefficient of y 4 and 6. Now find out the determinant of this. What is the determinant? 6 6 is 36 minus 9 4 is 36. Now this is 0. When the determinant is 0, that means this matrix is a singular matrix. That means this system of given equation, it can be inconsistent or it can be consistent with infinitely many solutions. There are two conditions, please remember. It can be, when the determinant is 0, there can be two conditions. Either the equations are inconsistent or they are consistent, but they are not having one solution, they are having infinitely many solutions because they both line are same. They are one over one another. So there is no two lines, there is only a single line. So what we'll do here is, the second case, adjoint A into B will find out. We'll find out the adjoint of the matrix. Then we'll multiply it with the B matrix, and then we'll see whether it comes to 0 or not. If this adjoint A into B is not coming to 0, then we say that it is the system of equations are consistent with infinitely many solutions. So there may be case where adjoint A is 0. So we'll take all that cases, but this question is saying that you have to show that it is consistent. When it is consistent and when they both are the same line, that means you will get infinitely many solutions. So I am just taking the adjoint now. I have exchanged the diagonal values and now change the sign of other values. This is adjoint A, and you have to divide it. This adjoint A has to be multiplied by the B matrix. What is B matrix here? 2 and 3. So multiply it with 2, 3 and see what comes. 6 minus 4, 6 minus 9, 6. So multiply it with 2, 3. 6 into 2, 12. Minus 4 is a 12. 9 to the 18 minus 18. And 6 is a 18. So you get plus 18. So this matrix adjoint A into B is also 0. When it is 0, that means that this system of equation will have infinitely many solutions. There are two things. Please remember once again. If determinant of A is 0, which is the case, and adjoint A into B is equal to 0, that is also the case, the system is inconsistent and the system is consistent and has infinitely many solutions. They both are same line. Again and again I am telling you, because this is the core of all the questions which are coming right after all this question. So first, determinant of A is 0. In this case, adjoint A into B is also 0. The system of equations are consistent and infinitely many solutions. So in order to solve this, we have to assume y equals k. Then first equation is 6x plus 4 into k, because y is k. 6x is 2 minus 4k. X is 2 minus 4k divided by 6. So you have a value of x, value of y, but they both are dependent on k, and you can take any value of k. That is why you are getting infinitely many solutions. But you have to check one more thing for the examiner to see. Put this x and y in this 9x plus 6y equals 3. I am putting it. So 9 into 2 minus 4k divided by 6 plus 6 into k equals 3. So this 3 3s are 9, 3 2s are 6. Now multiply whole equation left and right hand side by 2. So you get 3 into 2 minus 4k plus 6k, that is 12k equals 6, because we have multiplied by 2. So what do you get? 6 minus 4 is 12k plus 12k equals 6. This gets cancelled. 6 is equal to 6. That means that it is satisfying also. So clear? Show that the following system of linear equation is consistent and find their solution. So determinant of A will find out adjoint of A into B. If they both are 0, that means this system of equation are consistent and with infinitely many solutions. So the A is 2 3 6 9. So 18 minus 18 is 0. What do you get? 18 minus 18 equals 0. Determinant of A is 0. That means this is a singular matrix. Now we'll find adjoint of A multiplied by B. If this also comes to 0, then we'll do the same thing what we have done earlier. So adjoint of A, when adjoint of A is 0, that is a different scenario. We'll talk about that. The questions are coming. But right now, determinant of A equals 0 and adjoint of A into B equals 0 is our main key of these questions. So I am writing the adjoint and then multiplying it with B, 5 and 15, you get 0, 0. So when you get 0, 0, again, determinant of A is 0, adjoint of A into B is 0, they both are 0. That means infinitely many solutions, but the system are is consistent, because there are two lines which are actually one line and they are intersecting. That means you have infinite points of solution. Okay. So what you have to do here is you have to assume y equals k, 2x plus 3k equals 5, x will be equal to 5 minus 3k by 2. So x and y, they both are dependent on k. K can be chosen by you, any value you give, whichever is possible, and you will get infinite solutions. Infinite solution because of the k, and k is up to you. Right? Now this x equals 5 minus 3k and 2 divided by 2 and y equals k. This needs to be put in 6x plus 9y equals 15. Also to show that these two equations, which are actually one equation, I'll just show you how these are one equation. See, 2x plus 3y equals 5. Now multiply both sides by 3. What do you get? 6x plus 9y equals 15. And this is nothing but the second equation. Okay? Infinite solution. Show that the following system of linear equation is consistent and also find their solutions. So this will come as a 3 by 3 matrix. But the procedure will remain same. Ax equals b. What is a here? Let me write it. Coefficient of x 5 3 7. This is a I am writing. Coefficient of y 326 2. Coefficient of z 7 to 10. This is your a. Now what is x here? X will be x, y, z. What is b here? 4, 9 and 5. This is B matrix. A matrix you have, B matrix you have, and A X matrix you have. So first you have to find out the determinant of A. So you know how to find out the determinant. Let me tell you, the answer will come as 0. So now when the determinant is 0, there are two possibilities. Either the equations are inconsistent or they are consistent with infinitely many solution. In order to check the infinitely many solution, we have to find out the adjoint of A and we'll multiply it with matrix B and we'll see whether it is 0 or not. If it comes, then we can say consistent and infinitely many solution. So adjoint A into B is the second step what we have to do. I hope you'll be able to do that because adjoint of A we have already done number of times. If you have been following my discussions, we have been doing it quite a lot now. So this is adjoint A. Adjoint A, cofactor matrix transpose is adjoint A, and multiply with B. B I already showed you what is the B matrix, 495, and when you multiply it, it will be 0 again in this case. So when you have determinant of A as 0, adjoint of A multiplied by B is also 0. That means the equations are having infinitely many solutions. So same thing you have to do, but there is 3 by 3 matrix that will come as 2 by 2 matrix and you will solve like that what we have seen. So first Z equals K you have to assume. First equation will be 5x plus 3y plus 7k equals 4. I am taking 7k on the right hand side because it is constant. All constant has to be taken on right hand side. Say 3x plus 26y and 2z, that is 2k, has to be taken on the right hand side. So you get 9 minus 2k. Then you have 7x plus 2y. Take this 10k on right hand side. But you are not going to take the third equation. Why? Because third equation will use to show that the values which we get satisfy it. So first, here also you have to do the same thing, same procedure. Determinant A, please find out determinant of A. What is determinant of A? Because A, x equals B, x equals A inverse B, determinant of A is 26 into 5 minus 3 into 3. You'll say it will come as 121. That is determinant of A is not equal to 0. Then you have to find out the adjoint A. What is adjoint A? I am changing the sign, exchanging it and changing the other sign of other values. What is A inverse? Adjoint of A and divided by determinant of A. So this is determinant of 121 is the determinant of A. This is your matrix and this is your going to be A inverse. So now in order to find out x and y, A inverse into B you have to do Ax equals B, x will be equal to A inverse B. So this is 1 by 121, 26, negative 3, 5. And now you have to multiply it with the 4 minus 7k, 9 minus 2k, because this is in this matrix, these two are the constant values, our B matrix. Now when you solve this, you will get x and y in term of k, because what you have done, you have assumed z to be k. So you get 7 minus 16k by 11 here. Y will come as 3 plus k divided by 11. That means x and y are in terms of k. Z is already k. So this will give you infinitely many solution, because k is infinitely, you can give any value of your choice you can give. And the best way is to show the examiner is to take these three values, put it in 7x plus 2y plus 10z equals 5 and show it that these things, these values satisfy this equation. So now these type of questions are coming. Same thing, the procedure I told you, you have to adopt the same procedure here. Okay. So first is Ax equals B. Then you have to find out determinant of A. It is 0. Then you have to find out adjoint of A into B. If this also comes to be 0, then you will say infinitely many solution. In order to find out the solution, that is infinitely many solution, you have to assume Z to be K. Z is K. Now you make it as 2 by 2 matrix, that is Z will go, that is K will go on the right hand side, and then you will do it the same way. and find out the solution of x and y in terms of k. So x minus y equals 3 minus k, 2x plus y equals 2 plus k, minus x minus 2y equals 1 minus 2k. Use this, and same thing you have to do here with 2y2 matrix. So ax equals b, determinant of a you have to find out, adjoint of a you have to find out, a inverse you have to find out, put it in the x equals a inverse b, and then you will get the answer in terms of k. Because z is equals k, you already assumed. Put it in minus x minus 2y plus 2z equals 1 to satisfy it. So these questions are same. Just try it again and again. Now these type of question contains everything. They contain cofactor, they contain the transpose, they contain the adjoint, they contain the inverse. So this, you can say, amalgamation of all the matrices activities we have seen up till now. So all these you have to do, which I just explained you, and I will encourage you to first solve by yourself, then only try looking at the answers, because these are just for your reference. Show that each one of the following systems of linear equation is inconsistent. So it's a different kind of question, because you can say one option is used when the determinant a is 0 or not 0. So first we will do what? We will write this in matrix form, because we are solving using matrix. So ax is equal to b. What is a here? The coefficient of x, which is 2, 6. Coefficient of y, which is 5 and 15. This is your a. What is x here? X is x and y. What is b here? It's 7 and 13. Now, first of all, we'll try to find out the determinant of a. So 2 into 15 minus 5 into 6, you get 30 minus 30, that is 0. Now, since the determinant of a is 0, when it was not equal to 0, then we have some consistent solution. But when determinant of a is not equal to 0, and there can be two options now: consistent with infinite solution and inconsistent. That is, if you have a line and they are same line, or if the line are parallel, they will never intersect. Then the next step is finding out the adjoint a into b multiplied by b. Now when this also comes to 0, determinant a came 0, then adjoint of a dot b equals 0, then we say that we have infinitely many solutions. But if the determinant of a is equal to 0 and adjoint a into b is not equal to 0, then we will say inconsistent. These equations are inconsistent, because in the first case they are same line, almost similar. But if you see consistency with a proper solution, single solution, you have a single solution. They are intersecting. What is adjoint? Let us find adjoint. So I am exchanging 2 and 15 and changing the sign of 5 and 6. So this is your adjoint, and we have to multiply it by b, which is 7 and 13 in this case. So 15 into 7, which is going to be 105, minus 7 5 this 5, 15 5 and 5 and 13. Then minus 6 into 7 and then 2 into 30. So you get 105 minus 65 here, and then that is going to be 40, and here you have minus 42 plus 26. So 40 and minus 16 will come, and that is not equal to 0. This is not equal to 0. So as I said, when it is not equal to 0, that means it is inconsistent. Inconsistent, right? Now you know how to do this. So first of all, you have to write it in the form of ax b, then determinant of a. If it is 0, then try to find out adjoint a to b. If it is not equal to 0, then you can safely say that this system of equations are inconsistent. Show that each one of the following systems of linear equation is inconsistent. So I'll just go ahead. All this we have done. Show that each one of the following system of linear equation is inconsistent. So there are three equations. So first thing is that we are solving it by matrix. So Ax equals B. And in order to find out, the first thing is A. So I am writing the coefficient of X, coefficient of Y now, and coefficient of Z. And this is going to be your A matrix, right? And then what is going to be X? It is going to be X, Y and Z, because there are three variables. And this is equal to B, which is 2, -2 and -1, right? Now see, determinant of A we have to find out. Let me revise it for you. See, the determinant of A is 0 or not. If the determinant of A is not equal to 0, you will get solution, it is consistent. But if determinant of A is 0, if you are not equal to 0, then as I said, we already solved this type of questions. But determinant of A, if it is equal to 0, then what you will do? Adjoint of A into B you will find out. So adjoint of A and B, that is adjoint of A into B, in both the cases, one time it may come as 0, one time it may come not equal to 0. So when it comes to 0, then you will say that since determinant of A is 0, this is also 0. So we have infinitely many solutions and the system of equations are consistent. It is consistent, but since we have infinite solution, we will say that it is consistent. But here, if the determinant of A is 0 and adjoint of A multiplied by B is not equal to 0, then what we say? We say it is inconsistent. The given equation of our system of equations are inconsistent. So let us go ahead with this question. We have to find out the determinant of this particular matrix. So determinant of A will be equal to, so I hope you will be able to find it out, it is 0. So determinant of A is 0. Now we have to go to adjoint A into B. So we have to take the cofactor, then cofactor matrix you have to write, and then take the transpose, and that is going to be adjoint A. Let me write the adjoint A directly here. It's like these numbers are not important. The concept is important. Because if you know the concept, any equation, any number, you can solve it. So I'm writing adjoint A here, and I'm going to multiply this with the B matrix. What is B matrix? It is 2, -2 and -1. So the final result is not equal to 0. This is 2, -126 and 63. This is not equal to 0. So we can easily say that these linear equations are inconsistent. So what do you say? Because determinant of A is 0, but the adjoint A into B is not equal to 0. Inconsistent. Same thing you have to do here. Show that each one of the following system of linear equation is inconsistent. Just see here that let me just write this A matrix. So 3, 1, -1, -2, then X is 0, Y is 2, and then we have -1. Then X is 3, Y is -5, and Z is 0. So this is your A. Now determinant of A you have to find out. If it comes to 0, well, in this case it will come to 0. Then there can be two cases, whether adjoint, let me write it here like this. Adjoint A into B you have to find out. It can come as equal to 0. It may come not equal to 0. If it comes to 0, then we say that it is consistent, but it has infinitely many solutions when we both are going to come as 0. So infinite many solution in this case. But if determinant of A is 0, but the adjoint of A into B is not equal to 0, then you will say these systems of linear equation are inconsistent. So adjoint A, the cofactor matrix, transpose of that cofactor matrix is adjoint A. multiplied with b, which is 2 minus 1 and 3, it will not be equal to 0. So these are inconsistent. So inconsistency you know now. So same way you have to go ahead with this. Please remember, determinant of A 0, adjoint A into B not equal to 0. Determinant of A 0, adjoint of A into B not equal to 0. That means the linear equation or system of linear equation inconsistent. Determinant of A 0, adjoint of A multiplied by B equals to 0. That means the system of equations are consistent with infinitely many solutions. Now next one, A and B. These are two square matrices. So first we have to find out AB, and hence that means using this AB or solution of this AB, we have to solve this linear equation. But if you observe these equations very closely, you'll see x minus y equals 3, 2x plus 3y plus 4z equals 17, and y plus 2z equals 7. So what do you get here? You get a system of linear equation, and if I take write the A matrix for these three equations, wherever the values are not there, I'm putting 0. So when I make a matrix Ax equals B, for example, what will be A in this case? 1 minus 1 0, 2 3 4, and 0 1 2. Now this is A matrix which is given in the question as well. So same matrix is given, and these linear equations or these equations are giving us the same matrix. So eventually this A will be same as these. So what we have to do? We have to multiply A and B, and once we multiply, you will see that it will be a scalar matrix. You multiply A and B, it will be a scalar matrix, and 6, if you take outside, it will be 6 into identity matrix. Now the case is A, B, just as a linear algebra point of view, this A inverse can be computed here. So what you can do here is you can divide both sides by 6. It can be A by 6, it can be B by 6. So why not to give it B by 6? Because we are interested in A inverse. Okay, because A is eventually 6i by B. If you take B in the denominator, A inverse, let us invert it. It will be B inverse by 6i, that is 6 only. B by 6. A inverse is this. Okay. Now, if you want to solve this using A inverse, so A inverse is this. X is A inverse into B. What is B here? It should be 3, 17 and 7. But since we have to use this A inverse to solve these equations, so we'll use B as the 3, 17 and 7. B is not what this is given, okay? This is just B by 6. So B is matrix, will take B by 6. B is actual matrix we are taking, divided by 6. And the B in this case is not that B which is given as matrix, which we have found out, 3, 17, 7. And then we multiplied this. So what do you get? X, Y, Z, these are the values. This is how we are going to solve it. This is A. We have to find out A inverse and also to solve these equation. And when we actually observe and go deeper to these equations, you will eventually see that these equations are nothing but the matrix which is given. So 2 minus 3, 5. I am taking now 3, 2 minus 4 from the equation. Then 1, 1 and 1, 1 and 2. This is your A matrix. Now A inverse, so you have to take the inverse of this matrix. I hope you will be able to find out the A inverse, because X is equal to A inverse B. A inverse we have to find out what will be B. Let me write it here. It is 11. I'm writing B now. 11 and negative 5 and then minus 3. So just take the inverse of this A, multiply it with B, and you will get the solution. So A, first you have to find out determinant of A. It is not coming as 0. So you will get some solution XYZ precise solution. So now you have to find out the cofactor matrix of A. Then take the transpose. And then when you do this, divide it by adjoint of this determinant of A. So now this inverse has come. Multiply it with 11 minus 5, 3 minus 3, XYZ will come. Find A inverse if A is this. Hence solve the following system of linear equations. These are three equations: x plus 2y plus 5z equals 10, x minus y minus z equals minus 2, and 2x minus 3y minus z equals negative 11. So I am writing the coefficient of x, y, z in order to find out that A called matrix. So I am just writing these 2, 3, negative 1. This is the matrix already given to you in the question only. What is B? 10, negative 2 and negative 11. So find in A inverse. Of course you have to find out the A inverse. You have to find out the adjoint of A divided by the determinant of A. You will get the A inverse. And x equals A inverse B. A inverse multiplied using 10, negative 2 and negative 11. And what do you get? You will get the solution. Just see here. A is this. Determinant of A is equal to 0. Then there will be two cases. But determinant of A is not equal to 0. So you will get a precise solution. Consistent and precise solution. So cofactor matrix you can find out. Take the transpose of cofactor matrix, then divide it by using the determinant, which is 27 in this case. A inverse will come. Now A inverse has to be multiplied by B. What is B? B is 10, negative 2 and negative 11. Multiply this, you will get x, y, z. In this case, negative 1, negative 2 and 3 will come. Same thing here. A inverse, using A inverse, you have to find out the solution of this equation. Same thing. I'm just going forward now. So A is equal to this. And let me just give you the constant values here. See. 8 question has certain parts here. I don't know which edition you are using. You will find out which question actually is there in your edition. So I'm making the equation. It is basically 3x minus 4y plus 2z and 2x plus 3y plus 5z, x plus 0y, you can leave 0, plus z, and this is equal to, what is the constant value? I'll just write it here. It is negative 1 and 7 and 2. So what you have to do is, inverse I hope you will be able to find out, and multiply this inverse with this negative 1, 7, 2, and inverse multiply it with this matrix which is B, and you will get x, y and z. So A and B, same thing you have to do. So the equations are also given, and the coefficient of equation is nothing but A matrix only. And since we have already seen a question like this, let me write the B which we use in A, x equals B, which is, this is B, not B that is given in the question. So 10, 8, 7. And this A, B, when you multiply this, you will get a scalar matrix. So 11 you can take out. It will be, AB will be 11 into I. And in order to find out this A or A inverse, that will be B by 11, as I told you earlier also. Now take B, which is given in the question, divide by 11, and now multiply this with 10, 8 and 7. So when you multiply with 10, 8, 7, you will get the proper values, which is x equals 4, y equals negative 3 and z equals 1. I hope the concept is clear to you. Because The B which is given in the question is not what we are intending in the B which we are finding or we are giving. The sum of three numbers is 2. If twice the second number is added to the sum of first and third, the sum is 1. By adding second and third number to 5 times the first number, we get 6. Find the three numbers by using matrices. Now we have to solve this, you can say a sentence type of mathematical question with the help of matrices. So how we are going to make the equations? Sum of three numbers is 2. So let us assume one is x, the other is y, the third one is z. Sum of three numbers is 2, so x plus y plus z is equal to 2. This will be your first equation. Now, if twice the second number, what is the twice of second number? 2y, is added to the sum of first and third. The first is x and third is z. And when we add x and z with twice of the middle one, we get 1. This is your second equation. Then the third equation. By adding second and third number to 5 times the first number. First number is x, so make it 5x. And add it to the second and third. So we have 5x plus y plus z. And this is going to be equal to 6. Okay. Now find the three numbers by using matrices. So we already know that this x and y and z, how to solve this. We have a proper type of solution with the usage of matrices. So we'll do ax equals b. So this a is known, x is known, b is known. For that you need to understand, you need to know prior to this the inverse and matrix multiplication. So ax equals b. So what is the x coefficient of x and y and z? And what is b? 216. So let me write it here. So I am going to write the A matrix which you have to use. So it is going to be 1 1 5. Then we use the 1 2 1, that is the coefficient of y, coefficient of z is 1 1 1. This is your A matrix. Then x y z. This is your B matrix. Then we have 2 1 6, that is going to be your third matrix, which is B. So let us solve it. X is A inverse into B. So we'll take the inverse of this. And I hope you have a fair idea about finding out the inverse, because we already done that. So just find out the determinant of A so that you can check whether it is equal to 0 or not equal to 0. Then make a cofactor matrix. You know how to make it the cofactor matrix. Whichever element is there, just that row and column you are not going to use. The other numbers you are going to use. Find out the 2 by 2 matrix value, and then it is preceded by minus 1 to the power I plus j. I and j are the row and column numbers. So the odd addition will always give you negative and other will be positive. So this cofactor matrix, you have to find out the transpose of that cofactor matrix. You will get the adjoint of A, right? And then you have to divide this by the determinant of A, which is in this case negative 4. So A inverse is what? In this case, negative 1 by 4 multiplied by 1, 4, negative 9, 0, 9, minus 4, 4, negative 1, 0, 1. And this is your A inverse. You have to multiply this with B. What is B? You have 2, 1, 6. I hope you'll be able to do this matrix multiplication. X, Y, Z will come. X in this case will be 1. Y is negative 1. And Z is equal to 2. Right? So this is x1, y negative 1, z equals 2. This is how you have to follow the procedure. So other questions also you have to do the same thing. The main aim is to create the equations. Next one is an amount of rupees 10,000 is put into 3 investments at the rate of 10, 12 and 15% per annum. Now the combined income is rupees 1310. And the combined income of first and second investment is rupees 190 short of the income from the third. Find the investment in each using matrix method. So we assume that X, Y, Z, these are the investment. Total is of course 10,000, and 10% it is X. You have invested 10%, call it as X. In 12% you have invested Y, and 15% it is Z. Okay. So first thing is that X plus Y plus Z is nothing but 10,000. That is the total amount which we are talking about. That is X plus Y plus Z is equal to 10,000 is your first equation. And now the second equation. The combined income is rupees 1310, and the combined income of first and second investment is rupees 190 short of the income from the third. So the combined income is what? 10% of X plus this Y 12%, and Z you have 15%. So all these combined will give you a result of, that is the income of 1310. So 0.1x plus this is going to be 0.12 into Y, and plus 15 divided by 100 is 0.15, and this is going to be Z equals 10,000, and the income is 1310, that is the above 10,000, that is. So 1310 it is. Now the third equation is saying combined income of first and second investment is rupees 190 short of the income from the third. So when you add the first and the second investment, that is 0.1x plus the 0.12y, that is the combined income, is 190 short. It is less than the income of the third. So if you add this to the third one, that will equate these two, because the first two combined is 190 short. So why not to add 190, and you say that okay, that is equal, because we have to equate, we need an equation. So when you subtract this 190 from 0.15z, you will get equal to this one, or if it is short, you can add 190 to the left hand side. It's one and the same thing, right? That is the third equation. Let me rewrite this third equation, because this has to come here, and make it as a 190 so that you get negative on the left hand side. So I'm making this third equation. Okay, this is equal to 190. So this is first, this is second, this is third. Now we have these three equations. So AX equals B. A is what? It's 1, 0.1 and negative 0.1. These are all the coefficient of X. 1, 0.1 and negative 0.1. Now we have the Y. So coefficient of 1 is 1, 0.12 and negative 0.12. Then what is the coefficient of Z? It's 1, 0.15 and 0.15. So now we have this A. Now let us multiply this with X, Y, Z, because we have three variables, and this is equal to 10,000, 1310 and 190. That is the right hand side constants we are talking about. Okay, this is A, this is X, and this is B. So you have to find out X equals A inverse B. So this matrix, you have to find out the A inverse. I hope you have now a fair idea about finding out the inverse. Multiply it with the B, so matrix multiplication is also involved, and you can just equate this X, Y, Z. So I'll just show you the whole solution. If you're doing it by yourself, you can refer to the solution. I really encourage, don't see the solution until you are done. If you have any problem, then only come and see the solution. These are just for your reference, not because once, even if you try to solve it, if you don't understand, then you can take the reference of what I am guiding you as far as the making of equations are concerned. A company produces 3 products every day. Their production on a certain day is 45 tons. A company, 3 products are produced by this company. and their production on a certain day is 45 tons. So we know that three products X, Y, Z we can just add them and it is equivalent to 45 tons. It is found that the production of third product exceeds the production of first product by 8 tons, while the total production of first and third product is twice the production of second product. Determine the production level of each product using matrix method. So as I said initially, three products, let us assume it to be X, Y, and Z. And the first case is their production on a certain day is 45 tons. Just add them and equate it to 45 tons. So X plus Y plus Z is equal to 45. The second equation will be, see, it is found that the production of third product exceeds the production of the first product by 8 tons. So whenever there is an exceeding, you can just subtract it from the first or add it to the second one. So the third one is Z, first one is X, and when you want to equate this, since the third product exceeds the production of first product by 8 tons, what are you going to do? Z minus 8, then it will be then equal to X because it exceeds, so you have to subtract. So this will be minus X plus Z equals 8, negative X plus Z equals 8. So you can write this equation as negative X plus 0Y plus Z equals 8. This is your second equation. Now the third equation. So the total production of first and third product is twice the production of the second product. Okay, so the first one, then the third one, and this is, when you add, this is equal to the twice of the middle one, that is the second product, 2y. So you have the third equation as well. Well, let me write it like this. This will be X minus 2y, and it is negative 2y. 2y I am taking on the left hand side. So X minus 2y and plus Z is equal to 0. Right? So AX equals B we are going to use. X will be equal to A inverse B, and A is what we have seen in the previous question as well. So X will be equal to A inverse. Let me write it. You have to find out the inverse of this, which I am writing. 1, negative 1 and 1. I am writing the coefficient of X. It's actually 1, negative 1 and 1. It's 1, 0, negative 2. The coefficient of Y. Coefficient of Z is 1, 1, 1. And this inverse you have to compute. I hope you will be able to do it. And then we have 45, 8 and 0. And just multiply these two and you'll get X, Y and Z. This is the whole solution. If you are doing it by yourself, if you are stuck, just refer to this solution. But the main key is if you make the equation right, then the other things are quite easy. The prices of three commodities P, Q and R are rupees X, Y, Z per unit respectively. For P it is X, for Q it is Y, for R it is Z. A purchases of 4 units of R and sells 3 units of P. A is one entity, one man, one person, you can say a firm. So A purchases 4 units of R and sells 3 units of P and 5 units of Q. B purchases 3 units of Q and sells 2 units of P and 1 unit of R. C purchases 1 unit of P and sells 4 units of Q and 6 units of R. So by these you will get 3 equations. For A you will get whatever the total is, it's going to be 6,000 because this is the earning. The B has 5,000 and C is 13,000. If selling the units is positive earning and buying the units is negative earning, so if somebody earns, you have to take it as positive earning. Buying means if somebody is buying, it will be negative earning. Find the price per unit of 3 commodities by using matrix method. Okay. So let me write the first equation. For A I am making. A purchases 4 units of R. What is R? For R it is Z. So 4 times Z. And since it is purchasing, as I said, when we are purchasing or buying, it will be in negative. So you will have minus 4z. I hope you got this idea. Selling 3 units of P and selling 5 units of Q. So 3 into X and 5 into Y. What is the total? It's 6,000. I'll just write it 6,000. Now the second equation. B purchases, for B I am writing 3 units of Q. So first of all, whenever it is purchasing, you have to write it in negative 3y. And sells 2 units of P, so 2x, and then 1 unit of R plus Z equals, what is the amount? 5,000. Third one, I am talking about C now. C purchases 1 unit of P, so negative x, and 4 units of Q and 6 units of R, so 4y and 6z. This is equal to 13,000. Now these are 3 equations, and now we are ready for Ax equals B. X will be equal to A inverse B. Let me just write it. X equals A inverse B. A inverse, let me write the equation A. You have to find out the inverse. X coefficient, Y coefficient I am writing, then Z coefficient I am writing, negative 4, 1 and 6, and then you have to take the inverse. I hope you'll be able to do it. Multiplied by 6,000, 5,000 and 13,000. And when you multiply this, on the left hand side you will put x, y, z, and that x, y, z will be, I'll just show you the actual result here so that you can refer when you have actually solved this. Okay, so this will be your answer. The management committee of a residential colony decided to award some of its members, say X, for honesty. So X is for honesty. So there is a society, there is a colony, and they are giving some fund, you can say, and for their honesty, and Y for helping others, and for supervising the workers in order to keep the colony neat and clean, Z. So this is already given in the question. X, Y, Z is for what? The sum of all the awardees is 12. So the number is what we have to see here. X plus Y plus Z is equal to 12. Sum of awardees is 12. So first equation is this. If you are able to form the equation, as I told you already also, you will be able to solve the question. 3 times the sum of awardees of cooperation and supervision added to 2 times the number of awardees for honesty is 33. So what does that mean? See, 3 times the sum of awardees for cooperation and supervision. So we are talking about Y and we are talking about Z. So 3 times Y plus Z. Because you need to know what is X, what is Y, what is Z. So 3 times the Y plus Z, if, let me write it here, Y plus Z, added to 2 times the number of awardees. What is the 2 times of this one? 2 times the number of awardee for honesty. X is for honesty, so 2x. And this is equal to 33. If the sum of numbers of awardees for honesty and supervision is twice the number of awardees for helping others. So now again the third equation. If the sum of 3 awardees, sum of, that is X plus Z, and that is equal to 2y. Sum of the number of awardees for honesty and supervision, so X plus Z, this is equal to twice the number of awardees for helping others. So X plus Z equals 2y. Now let us form this equation properly, and we know if we are able to form the matrix and the constant, we'll be able to solve this. So X plus Y plus Z equals 12, 2x plus 3y plus 3z equals 33, and X plus, we can take 2y here on the negative, so X minus 2y plus this Z is equal to 0, right? So how to solve this? Ax equals B, X will be equal to A inverse B. So I'll tell you what matrix you need to form the inverse for, and then what matrix you have to multiply also. So I'm taking the coefficient of x, y, z 1, 2, 1, 1, 3, negative 2, 1, 3, 1. So this is your matrix. So x, y, z will be inverse of this. So I hope you'll be able to do the inverse. And the constant is 12, 33 and 0. Okay. Now inverse I leave it for you. Multiplication also I leave it for you. And in order to have a reference, the solution is in front of you. Okay. So first you have to find out the determinant, then adjoint divided by the adjoint by determinant, and just take the inverse and multiply it by the final constant value 12, 33, 0. Now A inverse matrix multiplication, you need to know about that. Then only you will be able to solve this type of question. A school wants to award its student for the values of honesty, regularity and hard work with a total cash award of 6,000. So this is X for honesty, Y for regularity and Z for hard work. The total cash award is X plus Y plus Z is given as 6,000, right? 3 times the award money for hard work. So hard work is what? Z. So 3 times the Z. If it is added to the see, it is honesty. Okay. For added the award money for honesty and added to what? 3Z is added to X. What is X? Honesty, right? There is no Y here. So we'll write just 0Y. And this is equal to 11,000, right? The award money given for honesty and hard work together is double the one given for regularity, right? So let us see this also. X plus Z, because X is for honesty, Z is for hard work. When we add this, and this is equal to 2Y, twice of the regularity. So third equation is X plus, I'm just writing 0 on the left hand side, but we are going to take this 2Y which is going to be on the right hand side on the left hand side. So X plus Z is equal to twice of Y, and so the constant will be 0 on the right hand side. Okay, so 2Y it is. So let me just reformulate this third equation. X minus 2Y plus Z equals 0. So what is the equation? Let me tell you again also. That is AX equals B. You know how you have to find out the A inverse and then multiply it by the constant on the right hand side. So 6,000, 11,000 and 0 here. What is this value? 1, 1, 1 and 1, 0, negative 2 and 1, 3, 1. This is 1, 3, 1. Okay. X, Y, Z. So X, Y, Z, in order to find out the X, Y, Z, what do you have to do? See, it is going to be the inverse of this matrix which I am writing right now, and multiplication of that inverse with the constant which is 6,000, 11,000 and 0 here, right? So I hope you'll be able to do the inverse and multiplication. Let me show you the final result. This is X and Y and Z. Just recheck if you are doing it by yourself. Two institutions decided to award their employees for 3 values of resourcefulness, competence and determination in the form of the prizes at the rate of X, Y, Z. So resourcefulness X, competence Y, determination Z. Now you know the idea how to do this. Okay, let me just formulate the equation quickly. The first institution decided to award respectively 432 employees with a total prize money of 37,000. So 4x plus 3y plus 2z equals 37,000. This will be your first equation. 4x plus 3y plus 2z equals 37,000. Let me write here. Now second institution decided to award respectively 534. So 5x, 3y, 4z, and that is going to be equal to 47,000. So this is our second equation. And what about the third equation? All the 3 per person together gets the amount for rupees 12,000. So just add x, y, z and you get 12,000. So let me just directly write x, y, z. What you have to do? You have to take the inverse of what? The coefficient of x, y, and z. That is 4, 5, 1, 3, 3, 1, and 2, 4, and 1. And just multiply this in inverse. First you have to find the inverse and then multiply it with this constant one. So I'm just writing the constant, and you have to multiply these two, and you'll get the result x, y, z. So the basic is to form the equation. Two factories decided to award their employees for 3 values of, first one is adaptable to new techniques, B is careful and alert in difficult situations, and third one is keeping calm in tense situations. What is the rate? X, Y, Z. So adaptable to new technique X, careful and alert in difficult situation, that is going to be Y, and third one, keeping calm in tense situation, that will assign it to the third one, which is your Z. Now everything is given in this question to formulate the equation, because 2, 4, 3 we can see, 5, 2, 3 we can see, and the total cost also we can see. So what is this here? This is X, this is Y and Z. A is X, B is Y, C is Z, and 2x plus 3y plus 4z. This is 2, 3, 4 actually. So just have a look at your book, this question, whichever edition you have. So let me write this as 2, 3, 4. 2x plus 3y plus 4z is equal to 29,000 here. Then we have the second factory, 5, 2, 3, 5x plus 2y plus 3z, and that is going to be equal to 30,500. So this, let me write 30,500. And finally, all the addition is 9,500. So x plus y plus z is equal to 9,500. This is going to be 9,500. Okay. 3 equations. Now see, this is the solution is different here. Why? And we have already solved an exercise with row transformation, the column transformation, to find out the inverse. Now here, all these 3 we are doing it. These 3. The actual scene is that there are constants. These constants are quite big numbers. So first, if you want to multiply taking the inverse with this, it's up to you. But the better way to solve when you have the values which are so higher than like this 29,000 and 30,500. So the best way is to solve it using the row transformation. And row transformation I have suggested on the left hand side. You can just have a look here. So row transformation, but you are free to do it using the normal method which we have been seeing up till now. This also you can do, right? Because doing this, solving with A inverse adjoint A divided by determinant A is always easy, right? But when it comes to multiplication, there will be certain issues which if it is in examination, then you can use this method. So there are 16 questions in my edition book which I'm taking, but still we will ponder upon, we'll talk about this. Okay, so 2 schools A and B want to award their students on the values of sincerity. Sincerity will be X, truthfulness will be Y, helpfulness will be Z. The school A wants to award X, Y, Z, each of these 3 respective values, 3 to 1. So just make it 3x plus 2y plus Z, and that is equal to 1600 here. And then we have school B wants to spend 2300 for 413, 4x plus y plus 3z, and that is going to be equal to 2300. And then if the total amount of award for one prize on each value is 900, so either you can write this equation at the top, or you can do it like that only, x plus y plus z equals 900. So let me write this x, y, z, and inverse of what you have to do. So I'm writing which inverse you have to take? 3, 4, 1. I'm writing the coefficient of x, y, z. Now you will see on the left hand side the solution. You will see that the order is different. This question specifically tells you, and the way I have written, that you may choose any equation in any order, because in that order the numbers on the right hand side constant will also change, right? So that will also change. So even if you take any order, the answer will remain same. It won't affect your answer. So just let me give you a quite small glimpse of this solution, so that if you are doing it by yourself, you can have a reference here. Okay, this is your answer. This also, 2 schools PNQ want to award discipline, politeness, punctuality. I hope you'll be able to do this, because x, y, z is already there. X plus y plus z, you can form 600 like that. This also, I'm just giving you an idea about tolerance, kindness. This also you can do. The total amount of 7,000 is deposited in 3 different saving bank accounts with annual interest rate 5%, 8%, 8.5%. So 7,000 was being deposited into 3 different bank accounts with 5%, 8%, and 8.5%. 8.5 is 8 2 is 16. 16 plus 1 is 17. That is going to be 17 by 2. The total annual interest for these 3 accounts is 550. Equal amounts have been deposited in 5% and 8%. So there will be no x, y, z. There will be only x and y. How? Because the x and y are same. It is given in equal amounts have been deposited. So what will be the equation here? See. Find the amount deposited in each of the 3 accounts with the help of matrices. First is 7,000, so you can just say x plus y plus z equals 7,000. But since there is no, there are only 2 values. X, first is xx, first value x, second value x, and third value y. So this 2x plus y equals 7,000. And what about the second equation? 5% of x, 8% of y. There is no y, there is x only, because x and the second value is x only. And third one is 17 by 2 into 100, that is 8.5%. This is going to be this value, 550. There are 2 equations. You just have to solve for x and y. It's quite easy, because 2 by 2 you know already. It's quite easy to find out the adjoint, but you have to do all the steps which we have discussed. Okay, matrix multiplication, inverse, transpose, all these you need to know before even attempting it. So this is a shopkeeper has 3 varieties of pens A, B, C. Now I will not use X, Y, Z, but we will use A, B, C. Meaning purchase 1 pen of each variety. So A, B, C, each variety, 1 variety A, 1 variety B, 1 variety C. So it means to purchase 1 pen of each variety for a total of 21. So A plus B plus C is 21. Given purchase 4 pens of A variety, 3 pens of 4A, 3 pens of B, so 3 into B plus 2 pens of C variety. So 2C equals 60 here. Now this Shikha 6A and 2B and 3 pens of C variety. So 3C equals 70. So what is the equation? Now I hope you'll be able to do it. This A, B, C will come here. And that is going to be the 1, 4, 6, 1, 3, 2 and 1, 2, 3. And this is going to be multiplied by, this inverse has to be multiplied by 21, 60 and 70. This is your final answer. So 5, 8 and 8, just recheck it if you are solving it. So this is all about this exercise. Thank you so much. Take care of yourself.